Today's lesson concerns the tangent ratio. This is one of the three main trigonometric ratios we're going to talk about, or trig ratios they are commonly referred to. We have sine, cosine, and today's is the tangent ratio. Tangent ratio is a very important one. It has lots of meanings in math, but here's what we need to know to make sure we understand what tangent and really all the trig ratios are all about. First of all, you need to know what this word means, opposite. In this regard, it means across from, adjacent, that means next to, and hypotenuse, that describes the side that is across from the right angle. So here is a triangle, TWO, and across from angle T, opposite from angle T, is side OW. So from T, the opposite side is OW. Adjacent to T is TO. This is why this is important. Tangent is defined as the opposite side over the adjacent side, a ratio, the opposite side over the adjacent side. And so therefore, the tangent of T is OW over TO. Now that's all fine and good. We got to put this into some usefulness math-wise, so here it comes. With the tangent being the opposite over the adjacent, here's a new triangle, TUV. It has sides of 4, 3, and 5. So, looking at it, across from U, the opposite side from U is 4. TV, which is equal to 4. And then from U, the adjacent side is UV, that's 3. So we simply put that into a ratio, and the tangent of U is equal to 4 over 3. Let's take a look at it again, only this time use the reference angle of angle T. Across from T, opposite of T, is UV, and UV is equal to 3. And the adjacent side to angle T is TV, and that is equal to 4. So the tangent of T is 3 over 4. Notice the relationship. The tangent of U is 4 over 3. The tangent of T is 3 over 4. They're reciprocals. That's an important thing to remember. Here's some notes you're going to need to fill in. I'll leave that to you. More notes, again, talking about the tangent of A and the tangent of B. This is angle A, so we've got 29 over 21, and so forth. This is the work that you're going to need to do. Now look, this really is as easy as it seems. Just so you know, you're going to need two answers. Two for number 1, 2 for number 2, and 2 for number 3. You're looking at what is the tangent ratio of E. So here's E, 6 over 8. From F, 8 over 6. That's it. There's nothing more to it. Now, finding some missing sides. This is the whole point of doing right-angle trigonometry. I've got a right triangle, and that's important too. It has to be a right triangle. I have an angle of 33 degrees, an angle of 57 degrees, a side over here that is 2.5, and a side here that I don't know. I want to find this side over here. This being the hypotenuse, I also might want to find at some point, but what I'm looking to find is side W. Here's what I do. From angle A, I'm going to make a ratio. Now, since I don't have the adjacent side, I'm just going to put it in as a variable. So the tangent of angle A is 2.5 over W. Now, that's not going to get us anywhere. Angle A is equal to 33 degrees. The two things I need to have one of the sides, and I need to have an angle measurement to be able to make this work. So I put it in as the tangent of 33 is equal to 2.5 over W. Now you're probably saying that doesn't really help me any. I don't know what to do yet. Well, let's do it this way. If I make it the tangent of 33 over 1 equals 2.5 over W, suddenly I've got something that may be familiar to you. I've set up a proportion. And now I can solve that proportion, and I'm hoping that you remember how to do that. Remember, I'm going to multiply diagonally, and then I'm going to divide by the other number that's left over. That's how you solve a proportion, or at least one way anyway. You're probably wondering, though, well, what am I going to do with this business here, the tangent of 33? How do I do that? Well, if you don't already know, let's take a look at the calculator, and what I've got here is a tangent button right there. Going to press that, and then put in whatever the angle measurement is when you get it. So we're going to get 2.5 times 1 is just going to be 2.5, and then divide that by the tangent of 33, and that will give us our answer, which is 3.85. That means that this missing side, W, is 3.85, and if we just use the eyeball test, this side is definitely longer than this side, so it seems like a reasonable potential answer. Now, finding a missing angle, this is a little bit different. Let's see what we've got. We've got an angle x, and we have an opposite side of 9 and an adjacent side of 3. So I can make the tangent of x be 9 over 3. There's a special way you have to do this. It's not hard. It's pretty easy, in fact. You're going to use what's called the inverse trig function. This is called either inverse tangent or sometimes arctangent, and it's written in this form. That means inverse of tangent. Here's where it is on the calculator. Again, it's the same button, but you're going to use the second function on there, just above that. So here's the calculator steps that you're going to use to solve this particular one. You'll hit second, then you'll hit the tangent button. That gives you arctangent. Then just put in 9 divided by 3, hit enter, and it gives you 30.96 is the answer, and that is an answer in a unit of degrees. So this means that it's 30.96 degrees. So what are you going to do with the work you've got to do later on in the practice part for 8-3? So we want to find the tangent of 46 degrees is equal to what over 12? This is simply a proportion. Remember that it's over 1, so you're going to do cross multiply and divide. This is going to be what's called the arctangent, so you're going to do what we just talked about a second ago, and then you're going to solve a proportion over here. Once again, this is the tangent of 12 over 1. Notes time, these are the kinds of problems that you tend to see with right angle trigonometry. You're standing right here and you're looking up at the top of a tree, and this is a 32-degree angle, and it's 125 feet between where you're standing and the bottom of the tree, and we want to find out how tall is the tree. Here's an example of the kind of problem you're going to see with inverse tangent, with finding the angle measurement. So we want to find the angle of r right here, and so we do what we just got through doing with arctangent. Now it's time for you to do a little bit of practice. Take a look at the quick check on page 151. Answers to the quick check. Very easy stuff here. Angle of K. Here's K. It's 3 over 7. That's the tangent. 7 over 3 is going to be the tangent ratio for angle J. How are they related? They're reciprocals. Now, finding the value of W to the nearest tenth, we've got an angle of 54 degrees, we've got an opposite side of W and an adjacent side of 10, so it's going to look like this. The tangent of 54 over 1 is equal to W over 10. That solves out to 13.8. A little bit opposite here, we've got the tangent of 28 degrees over 1 equals 1.0 over W. That comes out to 1.9. Finally, tangent of 33 degrees over 1 equals 2.5 over W. Last question. That, by the way, comes out to 3.8. The last question, we want to find a measure of angle y right here to the nearest degree. So our tangent is 100 over 41. Set it up like that. And then use the arctangent function. So 100 over 48 times this, the arctangent function, comes out to 68. So the measure of angle y is 68 degrees.